from Ims. So the project we have chosen for IMS project is the Smart Nursery Farm. So today I'm going to explain you our project and IMS project report. My name is Mohammad Amar. My group members are Abdul Wahab Qureshi and Asim Ali Shah. We have divided our project report and our work according to our capabilities. I was the team lead. I led and guided about project and made the project. I made the reports and implemented the sensors in project. Abdul Wahab Qureshi was the project manager. He helped in making the project, finding components and placing components. Asim Ali Shah made the PCB as soldered and interface sensor with Arduino. Our work in this project report is divided into three. I have written in red. The Abdul Wahab Qureshi has have written in blue. Asim Ali Shah is written in green. Acknowledgement. First of all, I would like to thank her. Because of you, we were able to make this project. Without you, it was not possible, as you have taught us about the interfacing of sensors with the Arduino and gave us knowledge of different kind of sensors. Abstract nursery farm management system can be useful to overcome a lot of challenges coming in the farming and nursery field. Uh, the sensor will do all the humanly work that is to be done physically. This saves hours of unnecessary wasting hours. Um, Nursery farming system is user friendly and accepts the hard work out of running your business by fixing facilities. Remember all the things that are important to your business. Nursery farming system collects data, important data and useful data, assesses information, implements the information and uses it to enhance crop growth and productivity. Basically, I was the team lead. Most of the work was done by me. I led and guided about the project, made it record and implement the sensor and project. I made the Arduino code on software, PCB and Proteus interface the sensor with Arduino code. My main sensor were current sensor DHT11 and LDR. So our estimated cost was initially we estimated the cost of from 4,500 to 6,000 PKR, depending upon the type of sensors. At that time, we thought about project concept was the the term smart agriculture refers to the uses of technologies like Internet of Things, sensors, location system, robots, and artificial intelligence on your farm. Uh, The data collected can be stored and done big data analysis. Users can go to the database to retrieve the information on growth environment of each batch of crop and do comparison and analysis. So basically, processes in smart nursery farm are four. It is data collection, diagnostics, decisions, and actions. What is the need of smart farming? Less human resources are input in farming industry due to daily hard work of patrolling in the field, fertilizing, water pumping, and spraying pesticide without actual day off. So this basically smart energy farm will help us in saving our time and our workload. This was the product design. Um, the main system with product design. This is the block diagram or the main system. We have basically these four sensors: ultrasonic sensors, temperature sensor, rail and soil, LDR. Apart from current and voltage, we have interfaces to Arduino, and with the help of Arduino, we activated the water pump, water sprinkler, and piezo alarm. I've also used the buzzer. We have used these components Arduino UNO. It is basically 14 digital input output pins. It has six analog inputs, 16 megahertz ceramic resonator. It has a USB connector, and you can tinker with your UNO without worrying too much about doing something wrong. Uh, Basically, one of my sensors were DHT11 humidity and temperature sensor. The DHT11 is a basic ultra low cost digital temperature and humidity sensor. It uses a capacitive humidity sensor and a thermistor to measure the surrounding air and spits out a digital signals on data pin. It is simple to use but requires careful timing to grab data. The DHT11 sensor can be either purchased as a sensor or as a module. I have choose the sensor because I did not need the module. Module has a filtering capacitor, so it has three pin. Uh, One is the bottom one is the VCC. The second one is the ground, and the last one is the out. The other sensor I used was the LDR, light dependent resistor. LDR, or the photoresistor, are often used in electronic circuit design where it is necessary to detect the presence or the level of light. These electronic components can be described by a variety of names, from light dependent resistor (LDR), photoresistor, or even photocell, or photoconductor. Although other electronic components such as photodiodes or phototransistors can be used, LDR photoresistors are particularly convenient to use in many electronic circuit designs. They provide large change in resistance for change in light level. This is the LDR. It has basically only two pins. I have used the LDR with a resistor. This is ultrasonic sensor. It was interfaced by Asim Ali Shah. Range sensor was interfaced by Abdul Wahab. Soil moisture was interfaced by Asim Ali Shah, and this one current sensor was interfaced by me. A current sensor is a device that detects and converts current to an easily measurable output voltage which is proportional to current environmental conditions. Among these sensors, a current sensing resistor is the most commonly used. It can be considered a current to voltage converter, where inserting a resistor into current path, the current is converted to voltage in a linear way. The technology used by current sensor is important because different sensors can have different characteristics for a variety of applications. Now that we have an idea of this current sensor, we'll take a look uh, on the principle a current sensor work. It can either be done through direct or indirect sensing. For direct sensing, it uses Ohm law. Voltage sensor was introduced by Abdul Wahab. This is the table I made, a characteristic of sensors. These are the sensors I've used: current sensor, LDR, and DHT11. The the threshold of current sensor is the switch relay on threshold. It has voltage. It requires voltage 3.3 to 5.5 volt. It has a range of 5 megahertz to 20 megahertz. LDR sensor is a threshold is satisfied. The voltage required is 5 volt, and it has a range of 0 to 1023 bits. The DHT11 sensor is high and it has threshold is high and low voltage threshold. Voltage is 3.3 volt to 5.5 volt. Its range is 0 to 50 degrees Celsius. The powers which were used were 220 AC to 12 volt DC power adapter, and the 12 volt to 5 volt DC power adapter. This is the submerged water pump that I've used in the project because We dipped it uh, into the what we say the container, and we then activated it through relay and coded the relay with the help of Arduino application. This is a schematic capture. We have basically used the Arduino cells. Uh, these are the connectors I have used, and in this we can see that I have used the LDR with resistor in parallel. Without the resistor, the LDR was not working. This is the PCB we have made using the schematic capture. These two were connected externally by the help of wire. All the PCB was soldered by Asimalisha. He etched it and soldered the components on it. This is the basic block diagram of Arduino. This is the LDR was connected to A0, voltage was connected to A1, current was connected to A2, pin was connected to A4. These four were connected to the analog pins of the Arduino. The soil moisture was connected to the digital pin 7, the ultrasonic. The trigger pin was connected to 4, and the echo pin was connected to 3. The HT11 was connected to digital pin 2. This was the Arduino code. This is the basically we have defined the I have defined the current sensor. I have connected it to A2 pin. This is the code of current sensor, uh, and I then defined the DHT11 sensor, and this is the LDR sensor I have defined. And then in the void loop, I called the LDR and DHT11. This is the code for the LDR current sensor and the DHT11. This is the working of Arduino. We will code Arduino in such a way that optimum time it will trigger relay which is connected to water. Basically the relay is connected to the water pump that the water moves from the one container to another. Um, we will also take input from humidity sensor to evaluate how much humidity is in the air. We use the LDR to detect darkness level and transmit resistance change to Arduino. This is the basic picture of the project. Project management, Amar. I listed down the components I chose and went to market for buying the required component. I searched a lot about the smart energy pump project. I googled the sensor pinouts configuration. I made sure what to do in the project. I connected the pins of the sensor and got information about the data, VCC and ground pin. Um, then I used Google to interface the sensors with Arduino and also did Arduino coding. I connected all the sensors with the Arduino and buzzer to check whether it works or not, and then it worked on breadboard. So my all sensors were working. So I basically designed my schematic capture of project circuit and the design the PCB myself. The other work I did was to connect the two motors and relay according to its requirement. I made the hardware of the project, interface the three sensors, current sensor at HT11, and the last one was the LDR. I made the outer hardware and interface my two sensors, the voltage sensor, the range sensor. So the total bill for the project was Is 8500. Conclusion: it was a really interesting project. We as a group collectively made this project. We learned a lot by this particular project. Now coming on to the project. This is the Arduino Uno we have used. This it has 14 pins. This is the relay, double relay I used. Um it was to run the two motors which I have used in this project. This is the motor. This is submerged motor. Um, it is partially dipped in water, and it it pulls the water and moves the water through the pipes to the other container. This is the DHT11. It calculates temperature and humidity. This is, I think, this is the voltage sensor I've used. This is the current sensor I've used. It has basically three pins. This is the ultrasonic sensor having four pins. The the middle two are the echo pin and trigger pin. This is the soil moisture sensor I have used to calculate the moisture of the soil, and this is the rain sensor finally I have used. This is the buzzer I have used. This is the PCB I made. Basically, it was having some problems, like as you can see, sir, that there are problems here. I soldered it, and the circuit was not working. So after soldering, it worked. And these are the connectors. These are the female connectors, and these are the male connectors. Male connectors were for the Arduino, and the female connectors were for the sensors. And this is the wire which I earlier showed you on the PCB. We have connected it externally. So basically, this is our project in our daylight. It works like this. So I will explain it to you a little. That is, so when you can see, basically we have two motors. When there is no rain on or on the rain sensor detect there is no rain, the sensor starts the motor with the help of relay. The water moves from the tank outside to the inside of the container. We have coded the Arduino in such a way that the optimum time it will trigger relay. The water pump will spray water on plants. Uh, The ultrasonic sensor is just used as water level indicator. If water becomes less, then the relay will again on the water pump. The DHT level will uh, detect the temperature and humidity. In case of fire, it will off the water sprinkler. The soil moisture will activate relay uh, to move water to plants, and the LDR is connected in parallel with the resistor. LDR is used to detect darkness level, whether it requires the artificial light of LEDs or not. That's the working explanation of the Smart Nursery Farm project. This is the video of project at night time. So we have no light. Um, it basically has the LDR, sorry, the LEDs. With the help of LEDs, it gives signal to the relay. So this is the project report and project video I had to explain. Thank you.